Okay, for this part, you have to count the numbers that are between these two intervals. So we want to look up here and see how many numbers fall in between this range. So we have the 2, so that's 1, 18, no, 2 doesn't fall, 18 does, 17 does. So what you can do is just kind of list out the numbers that fall in between there. So we have 18, let's go across. We have 17, 16, 35 and 36 and 37 don't fall in between them. 33, 34, and 20 do. 18, 30, 28, 32, 31, 20, 17, 26, and then 23. All of those numbers fall in between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers fall within one standard deviation. So what we want to do is we want to take, we have 14 numbers or values, and we want to divide that by the total number of values. So 14 divided by 18 is, okay, so then we're going to round to the nearest percent. So let's times this by 100 to change it to a percent. So 77% would round up to 78%. Okay, and then it's asked to calculate the interval x plus 2 times s. So we would just do our mean plus 2 times 9.3. So let's work that part. Let's look at that part so you'll understand how to plug these numbers in. So we're doing x plus 2s. And x, I believe, was 25. X bar, which is the mean, is 25.28. And then S is 9.3. So you're going to do 25.28 plus and minus to get your interval. So our first value would be 25 plus 2 times 9.3. Oh, 25.28 plus 2 times 9.3. You should get 43.88, and then 25.28 minus 2 times 9.3, and you will get 6.68. So 43.88 is our high number, and 6.68 and then 6.68. Now, okay, the next part wants to know how many numbers fall within that. So between 6.68 and 43.88. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 of them out of 18. So you're going to do 17 divided by 18. It's always the amount of numbers divided by the total amount. And then you're going to times that by 100 and round it to the nearest percent, so it would stay 94%. Alright, now I'm guessing the next part is the 3 standard deviations. So this time we're going to do 3. And hopefully all our numbers will fall within 3 standard deviations. So if they do, then we know that's 100%. 25.28 plus 3 times 9.3 is 53.18, and 25.28 minus 3 times 9.3 would be a negative 2.62, but this may be a trick question. You can't throw negative passes, so let's just try we'll try negative 2.62 first, and then we'll change it to 0 if it doesn't work. 53.18. So 53.18. Okay, so that did work, and I can go ahead and tell you that every number up here is in between 3 standard deviations, because 2 is the only number that we didn't have that fell within this range. So let me know if you have any questions about this one. Oh wait, do these percentages agree with Chebyshev's theorem? Let's see. All the percentages agree with Chebyshev's theorem. The percentage does not agree. None of the percentages agree with Chebyshev's theorem. So let's look at that real quick. Okay, so before we can answer this, you have to understand what Chebyshev's theorem says. It can apply to any data set. It doesn't have to be a normal distribution, like a normal bell-shaped curve. It can be any curve. So it doesn't give us any useful information on one standard deviation, so we don't have to look at that. But it says at least 75% should fall within 2, and it does, because we have 94% is greater than 75 at least. And then at least 89% will fall within 3, and ours falls 100% falls within 3. So as long as the 2 standard deviations is 75% or greater, and as long as 3 standard deviations is 89% or greater, then the percentage agrees with Chebyshev's theorem. So just to make sure we understand what Chebyshev's theorem says, we know in a normal distribution it's 1 standard deviation, 68% fall within 1. 2 standard deviations, 2 standard deviations is 95%, and then 3 standard deviations is 99.7%. That's the percentage of numbers that will fall within that standard deviation. That's if you have a bell-shaped curve like that. And I did a video on the problem before this one in the homework where I go over these, and I think it's also in the module, chapter 3, about the bell shape. But Chebyshev's theorem says 1 standard deviation, they don't give you a percentage, but 2 standard deviations has to be greater than or equal to 75%. And then 3 standard deviations has to be, I can't remember that number. Let me look that up. Okay, Chebyshev's theorem, has to be greater than or 89%. This one's, you can use this theorem for any shaped distribution. If it's skewed or whatever, right skewed, left skewed. But the empirical rule, you can only use when it's normally distributed around the mean. Let me know if you have any questions about this one.